Welcome to our presentation. My name is Pankaj. I'm going to present our research on extracting rationale behind open source software development decisions using a case study of the Python email archives. My presentation today is structured as follows. One of the keys to success of an open source project is the governance model. However, certain decision-making information is not totally transparent. Here we show the process model of Python enhancement proposals. As you can see, how proposals are accepted or rejected, the rationale behind decisions are not clear. To extract this information, one would have to go through a large number of emails. To automate this process, current causal extraction techniques are limited, especially dealing with complex sentences and when the cause and effect, which relate to the decision and the rationale behind the decision, are in totally different email messages. Therefore, a more holistic approach is needed. There are several reasons why we chose the Python project for a case study. The main reason is that it practices both a meritocracy and dictatorship decision-making approach, and seldom have these projects been investigated. So our research questions are basically, what are the different rationale? How can we extract them automatically? And what is the effectiveness of our approach? This information would be useful for new members of the project and stakeholders of the project. Our methodology was basically divided into 9 steps. The first 3 steps were dealt with data extraction. Then we established the ground truth, and in establishing the ground truth, we identified patterns which could be used to mine the rationale. Then we ranked the candidate sentences using 2 schemes, sentence-based scheme and message-based scheme. We will describe this shortly. And then we evaluated the performance of these schemes, and then finally we ranked and presented these sentences in a graphical user interface. The ground truth extraction phase focused on extracting the rationale behind all the accepted and rejected PEPs. There were 248 of these. And in doing so, we identified patterns in the way rationale behind decisions were stated. The rationale can be stated in a number of different ways. The rationale and the decision, more formally called the cause and effect, can be stated in the same sentence clause, and which could be extracted using triple extraction. It can be in the same sentence, could be in adjacent sentences, and in totally different email messages. Here we show the 4 different types of email messages which could contain the rationale behind the accepted or rejected decision. We identified 6 different types of terms used when rationale are expressed, and these can be used in patterns within a sentence, in a sentence in combination with the rest of the paragraph, and in the message subject. In total, we identified 13 heuristics which belong to 5 categories. These were term-based patterns, proximity-based, role-based, and response to certain messages, and special terms. And the final heuristic score was the combination of all these 13 heuristics. We evaluated the ranking of the rationale miner tool using standard information retrieval metrics, since we have 2 schemes and we ranked accepted and rejected PEPs separately. Thus, we used the normalized discounted cumulative gain metric, and the average value of uh, normalized discounted cumulative gain was calculated using the following formula. Now the results of RQ1, we found out that most of the rationale behind PEP decisions imply that but the Python community collective view was given more preference. There were few instances where the BDFL overrode the collective community view. However, these were very few. We also identified the instances of rough consensus, which is a new find in the literature on empirical studies on rationale behind decisions in open source software development. Now we also wanted to find out which were the most influential heuristics which helped the tool rank the sentences more towards the top. So if we found if the rationale was stated within this clause, if the rationale and the decision was stated within a clause within a sentence, and if that was captured, that had a strong influence on the ranking. This was followed by term patterns in the current sentence and the days from the state change and the decision terms in message. We had two approaches to rank the candidate reason sentences and messages. One is sentence based and the message based. The message based scheme basically aggregates the sentence based scheme. Now in this figure we show an example of the PEP 308 when we are trying to extract the rationale for PEP 308. The panel 1 is where the parameters are entered upon which the messages for the PEP are shown, and on panel 4 if we want to see the rationale behind decision, we can choose the sentence based scheme or the message based scheme, and we can also choose the whether we want to see the computed metrics for the accepted or rejected PEPs. The accepted and rejected PEPs are the metrics for accepted and rejected are computed separately because PEP 308 for instance had both accepted and rejected. It was first rejected and then accepted. So you can see the example shows in panel 3 you can see the sentences are marked. In the message based scheme the sentences are marked, so it makes it easier for the user to locate the sentences. We evaluated the ranking and using the NDCG values, and NDCG is a metric which penalizes the ranking evaluation if the ranking of the tool is not ranked at ideal ranking. So every time we are not able to rank it at the top level, and the more our sentences are ranked lower, then the penalty increases. So we found that the message based scheme for both accepted and rejected PEPs is closer to the ideal ranking. Now the reason that the ranking never goes to the maximum level of 1 is that some of the rationale don't conform to any of the patterns we have identified. So therefore they are not captured in our model. And in our study we have found that in Python the collective view of the community is mainly given preference, and it seems to work well for the decision making within Python. For the research question 2, we have identified a heuristic-based rational minor approach, which has got two schemes. And for the research question 3, we have found that the message-based scheme is best performing of the two schemes. In conclusion, we have identified 11 different ways of decision and of reaching a decision outcome. I proposed a heuristic-based approach, and the tool we have developed can reasonably rank candidate rational sentences and messages. The tool can be extracted to be used in other OSS communities. Our findings can be used by researchers and new members to the Python project, and to better understand the decision making process in Python. Thank you. Any questions?
So hello everyone. It's great to have all of you here in this wonderful session. In this session, we have a nice mix of papers about open source general issues, technical track paper, which was this one that was just presented. Then we'll have a software engineering practice paper and a software engineering society paper following up. So if you have any questions for this first paper, Mr. Sharma is really keen to receive them. I'll wait a couple of seconds to see if any question pops up. If no questions pop up, I will start with my questions. Okay, so the first question that I have, Mr. Sharma, is about Dr. Sharma is about the perception of other contributors. I don't know if you had the opportunity to look at it. It's like, how do other contributors perceive the decision making process? Because here you're looking from the perspective of what is going on in the mailing list and what are the kinds of rationale that ended up. But have you, for any reason, for any chance, analyzed how people perceive how the decisions are made?
Yes, so the Python community is made of two major groups: the developers and the users. And it has been in the Python project website. It is clearly laid out that the decisions are made based on the core developer's view. Sometimes the user's view is considered, but not they are not they because the users view in terms of longevity of their applications, and developers view in terms of the longevity of the language. So there is a differentiation happens that the developers should view to improve the language, while users just want to maintain their applications. They don't want to make changes. So in that, sometimes what happens, the users, there will be conflicts between the users and developers, and we have found three instances where these were made explicit. One or two of the cases, it's explicitly right out that the users community uh, rejected the proposal, so they wouldn't proceed any further. But most of the time, the decisions are made on the core developer's view. Now, yes, you've raised a very good view. How is this? How do the people take the decisions? And what happened that caused the Python BDFL to resign on 11th of July 2018? What led up to him resigning from his position? So that's one area we actually have published one paper on influence of roles in decision making about 1 or 2 months ago at the East conference this year, which we're going to present next month. However, we want to go deeper into this. This was a first step, and next one we want to go deeper. We want to find out how these decisions are perceived, but not only in Python, because there's only two groups. We want to look at Bitcoin, the Bitcoin community, because there are three groups: users, developers, and miners. And that's one area we want to know. How are these decisions perceived? What are the people's view? And what causes someone to just leave, the BDFL to leave, or people to just leave the community totally? How do sentiments build up? How do things, what causes them? How do things build up?
Okay,
It's our feature.
thank you. It's a great answer. So Celila has another question in the chat. So good work. A decision could be influenced by many factors. How did you decide the factors, and how did you identify trade-offs in these decisions?
We mainly focused on how decisions were made. Whether in Python, for example, there's a mixture of the dictatorship and meritocracy model. We wanted to know that while the decision-making process has been advertised on the Python website, but based on a data-driven study, we want to know what actually happens. How are decisions actually made rather than what is being advertised as being made. So we in this paper we only focus on how decisions were made, not the factors behind the decisions. So we went, we manually went through the 248 accepted and rejected PEPs and the mailing list messages for those, and try to pinpoint the exact sentence which actually says whether the BDFL made his decision on his own, or what is based on the community consensus or lazy consensus. We only found few instances, 1 or 2 instances, where the BDFL overrode the community consensus. So that's what we were mostly interested in. Now, your question is, a decision could be influenced by many factors. How did you decide the factors? Now, we only focused on whether it was one person making the decision, or was it the community view. That is what we pinpointed upon. The other decision making factors, what I would really interested to know what the other factors could be, and we can research on those, to be honest.
Thank you. We have another question from Felipe. Does your approach, can your approach be used to identify rationale related to other aspects other than patch acceptance, PEP acceptance rejection?
Yes.
I mean, in more specific case, for example, the rationale within a code change to use a while instead of a for, or it's just related to PEPs?
So the PEPs is a special case because each PEP, so the 466 PEPs in Python before when the BDFL resigned, so each the all messages related to a particular PEP has the PEP number 1, the PEP number 572, for example. Now the decision and the cause behind the decision could be in different email messages. The difficult thing was to relate. So one particular PEP could have like about 250 email messages. How do you relate? The decision could be in one email message. The cause could be in totally separate one. And it's in causal extraction is a difficult problem to solve, because causal extraction at the moment only deals with when the cause and effect are in the same sentence or adjacent sentences. Forget about in totally different email messages. So how do we do this? So we came up with a heuristic-based approach. Yes, this can be applied. However, the heuristics needs to be modeled. The heuristics would need to be remodeled, and some of the heuristics maybe if we take a more exploratory study of the domain, we can add more heuristics and maybe remove some as well. But so there will be some manual exploratory study required. In whichever domain we want to implement it, but in terms of what we propose is a product which can be applied to email archives, and when the decision and the cause in different email messages.
So we still have around 2 minutes, and I have another question. It's a curiosity that I have when that came up when reading your paper. Like, was there? Did you find any after acceptance or after rejection discussions that were really I don't know if made people change their decisions or whatever? If got a great repercussion in the mailing lists?
We for this paper we were interested in the sentences which led up to the decision, which the close as soon as a PEP is accepted or rejected, the
Okay, the author dropped from the room. Let's just wait to see if he's coming back. So meanwhile, let me just present the next paper. So the next paper is a software engineering practice paper. It's an empirical study of the landscape of open source projects in Baidu, Alibaba, and Tencent. And it's conducted by authors from Chinese universities and Hui. And feel free to join the discussion room if you want to keep discussing with this author. I hope he's there. So click in the bottom right